Hi guys. This one of our lecture series for core mathematics. This will be lesson one because it's a fresh topic. Yeah, sequences and series. This topic it's both in core mathematics and elective math. So I'll try and give you an in-depth explanation of what you need to know about this, and I'll do my best to cover every aspect of the syllable. Before we begin, we need to know what sequences are and series are. Okay. So, yes, before I start, can someone tell me what a series is? Series. Yes.
It is the continual reoccurrence of something.
Mm, Okay, that's something we all commonly know, but you didn't define it right. Okay, so let's write something. Sequence. Let's write. A sequence is a set of numbers written in a defined order. Yeah, a sequence. A sequence is a set of numbers written in a defined order with a rule or formula for obtaining the terms. With a rule or formula for obtaining the terms. Okay, so that's it. It's a number pattern. Okay, that is written in a definite order, and to obtain the subsequent terms, there is one kind of rule that is used to obtain them. So an example is what is written over here. So we have 1, 3, 5, 7, 9. This is a sequence. You can see that it's in a pattern, right? And to get the next term, it looks like you simply have to add what? Two to it, right? To get 3, you add 2 to 1. To get 5, you add 2 to 3, right? To get 7, you add 2 to 5, like that. So, Jessica, can you continue for me? After 9,
11.
yeah, after 9, what do you think will be there?
So 12. And 11.
Did she eat during break time? 11. What else again? Come on, the next numbers. Well, that help.
13.
13. Yeah, right.
6.
Okay, yeah, 11, 13, 15, and so on and so forth. Guys, you get it. Okay, sorry, I'm a bit distracted because I'm doing something. Just a moment, guys. Just a moment, please. Okay. Madam Precious, when I'm done, I'll get back to you. Yeah, so we have, is she in the classroom?
Okay. So I'm here.
All right. The next set of numbers, you have 2, 4, 6, dot, dot. So this what? A sequence, right? It's a number sequence because it's in the form of what? A pattern, isn't it? Of course, there is a rule to get the subsequent numbers right. From this, what can you conclude? What's the next number?
8.
8. Then the next.
10. 12.
10, 12, and so on and so forth. Okay. Now let's come to series. Sometimes it's not going to be easy for you like this one. You know, I have to rack your brain. Let's come to series. So series is when you sum the terms in the sequence. Oh, in case you want a nice definition for your notebooks, so some of you can write this that a series is formed when the terms of a sequence are added. A series is formed when the terms of a sequence, right? When the term of a sequence.
That means you can't see what I write.
I thought I'm sharing my screen.
It's added.
I thought I'm sharing my screen, guys. You can see. Is it that my handwriting is too small?
You can't see on the screen.
Really? You can't see my whole screen.
You can't see.
What's going on? Because it shows here that I'm sharing my screen.
You can't see. It's like after the series, you can see.
Hold on.
Then we can see. It's not from your side.
Okay.
No, are you talking about it's going down or
They don't have lights.
It's formed when the terms of a sequence are added. I'm waiting for you guys. Okay. So now you can see my screen, right?
Yeah.
So now the moment, so what you see above 1, 3, 5, 7, 9 was what sequences, right? Now when we are adding them, 1 plus 3 plus 5, right? Plus 7 plus 9 plus 11 and so on and so forth, right? This is a series. In the same vein, that sequence can be represented as series when we start to add them. So 2 plus 4 plus 6 plus 8 plus 10, right? Well, that I want to, no, I've been calling her name today. Let me call someone else. What is that? Andrews is there. Andrews, continue. Plus 10.
Plus 12.
Plus 12, yeah. It's sorry. Hold on. Yeah, hold on. Yeah, plus 12.
But
Yeah. Plus, I mean, dot, right? So that's a series. At this point, let me know if you have any question for me.
Yes.
Hey, Patience, I've never called her. Do you have any question? Patience is there, Linda is there. Okay, the next set of questions, it will come to you. Do you have any question so far?
That is no.
Can I move on?
No. Yes,
Can I
sir.
move on?
Yes, like that.
Okay, now pay attention. Listen, don't joke with this. Very examinable. Every year, when questions comes and we solving, I see them all running all through and through. So don't joke with that. Okay. Now, the numbers in sequences are called terms. So the items in sequences, all right, are called terms. Okay. So this one is a term, this one is a term, this one is a term, like that. Is that okay? Yeah.
No, sir.
This, yes. Can you hear me?
So if you say what's
The
the
network is not stable. I'm buying bundle.
When you are done, let me know. Okay, so let me repeat myself. So I was saying that, sorry, I was saying that the terms in a sequence or a series, okay, sorry, the items or the numbers in a sequence or a series are called terms. The items in a sequence or a series are called terms, okay? So that 1, that 3, that 5, that 7, they are called what? Terms, okay? Let's come to the series. That 2, that 4, that 6, they are all called terms, right? So what is beginning is called the first term. The next is the second term. The next is the third term. The next is the fourth. The next is the fifth, right? So now I have a question for you. For the sequence 2, 4, 6, 8, 10, 12. Now, are these people ready? For that sequence, Linda, what is the fourth term for that sequence? This sequence. 2, 4, 6, 8, 10. What's the fourth term, Jessica?
8.
It's 8. So just so you know, the word I'm pronouncing is what? Terms. Okay. She's right. And Venice, for that same sequence, what is the third term?
6.
Say that again.
6.
6. Now, let's continue. Now, we have two types of sequences. So now, enough of the theory. Let's go to practicals. Calculation, sorry. Okay, so let's look at types of sequences. So we have two types of sequences. Who can name them? Who has a clue of what they could be? Who has a clue?
10.
Yes.
The
Say that again.
arithmetic sequence. Arithmetic sequence.
Yeah, right. Arithmetic progression. That's the word. Arithmetic. Okay. Progressions. Okay. Please hold on. Arithmetic progression. Okay. Also called the linear sequence. And we'll look at that. So if you hear AP, okay, AP, then we're talking about arithmetic or progression. Okay, arithmetic, the whole class. Arithmetic, progression. Okay. Then the next one, yes. Can someone do us the honor? So it's called geometric progression. Oh, I didn't spell that right. Progression. We wrote progress. Progression. Right? Geometric progression. Also called what? Yes. Okay. Yeah, it's also called what? It starts with E. Exponential. Exponential sequence. Okay. This is also called GP, of course. So if you meet GP anywhere, it's what? Geometrical progression. Okay. So now we're going to start with arithmetic progression. Arithmetic what? Progression. Can we begin? So, no, okay, I'll wait for you. Oh, you still there or you are done? Don't waste the time. What's the time? Yeah, so arithmetic progression. So this is a kind of sequence in which each term differs by the preceding term by a constant. Okay, a constant called the common difference. Yeah, so this is, I'll explain. This is the type of sequence. Hold on. Yeah, there's a type of sequence.
Small time.
In which any term differs from the preceding term by a constant, right? Constant. Yeah, I'll explain. Let's add up. The constant is called the common difference. Okay. And may be positive or negative. Move on.
Yes.
Okay, yeah, so that's it. I just wanted you to know. I can actually, most of the examples touched on arithmetic progression, but yeah, we'll look at that. Let me know when you are done. Let me know when you are done writing. So, guys, can I continue?
Yes.
So, this is an example. What we wrote earlier, 1, 3, 5, 7, 1, 3, 5, 7, 9, right? So, you see, when we say preceding term, that's what comes before. So, if you take 3, what precedes 3? That's 1. 1 came before 3, right? So if you're looking at 5 and 3, 3 is the precedent, right? 3 came before 5. Do you get it? And we are seeing that in arithmetic progression, there's a kind of or type of sequence where any term differs from the preceding term by a constant. So by a constant, and that word constant should be taken seriously. What it means is that before you move to 3, okay, before you move to 3, 2 was added, isn't it? So the constant is 2, right? 3 differs with the preceding term by what? 2. You can check 3 minus 1 is what? 2, right? 3 differs from the preceding term by what? 2, isn't it? Now, we are seeing this as AP, an arithmetic progression. What it means is that then throughout the sequence, all the terms differs from their adjacent preceding term by 2. And it's true, right? So discovering that from 1 to 3, you move the difference is 2, meaning is the difference is 2 for all. So we can be able to generate the sequence, the rest of the sequence, right? So when you take 5 and 7, the preceding term is 5, right? Now the 7 differs by 5, differs from 5 by what? 2. You get a point. 9 differs from 7 by what? 2, right? So in AP, any of the term differs from its preceding term by a constant. It's a constant and it runs throughout. That's what AP is. So it's not like at one point, it differs by 3, and like in another section of the sequence is different by 4 or 5, right? No, we said it differs by a certain constant. Guys, you get me?
Yeah.
That's for AP. And mind you, it's not all the time the difference could be positive, it could be positive, it can be negative. And we'll be looking at those examples very soon. Okay. Now, that constant, which is 2, is called the common difference. Okay. It's called the common difference. So I can give you another example right here. So look at this. 32, 27, 22, 17. This is a sequence. In fact, it's an arithmetic progression. Why? Can someone come in? Why? 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 Where's my calculator? Mm-hmm. It's an AP, or you disagree with me? Hello.
Hi.
Yeah, so are you guys lost?
Sir, please no.
What's the next term? Anyone can come in. What's the next term? What's the next term? I mean, what's the fifth term?
That's all. Oh, this is
Um,
12.
no,
That is 12. That's 12.
it's wrong.
So how? Because each term has been
Oh,
reduced
yeah, that's
by
five. That's five. Yeah, so yeah, it's 12. Yeah, it's 12. It's 12. Yeah, it's 12. You got it. So hold on. So it's witness that. So you see here, each term differs by a -4. Don't worry your head about how the negative came. I think you are doing some kind of reasoning in your head, right? But it's -4, and I will show you that thing you are doing in your head, okay? It's right. That's what you did to get a 12. But the difference is it's -4. So -4 is a constant. -4 is a constant. That's how come 17. No, is it -4? -5, sorry. -5. So that's how come 17 to get the other term. You said 12. How did you get that? You subtracted 5, that -5 from what? 17, right? And then you had what? Check it out. That's going to be 12. Hmm? Yeah, so you reduce it by what? You reduce it by 5, not adding. May I know if you get a point?
Yes, sir.
But I'm going to make it better as we progress. So do not worry about that -5 or 2. So the point is that in arithmetic progressions, each term differs from the preceding term by a constant. Okay. Now that constant is called the common difference. It can be positive or negative, and that's what I've shown here. Now let me show you how we get a common difference. Okay. So that constant is called common difference. Okay. And we use D to represent that. So if you see D anywhere, is what? It's called what? Common difference, or that constant, common difference. Common difference. And I'm going to show you how it's done. Okay. So to get a common difference, it's either you subtracting, so it's U2, as in the second term. We'll talk about the denominations, sorry, the denotion soon. It's either you are subtracting the first term from the second term. This U there represent terms, okay? Terms. It represent terms. So if I bring n here, I mean the n terms, right? So if you see one, the meaning first term. If you see two, the second term, right? So to find the common difference, it's all about what? Taking the second term, which is what? Which is 27, right? Then minus the first term, which is what? 32. Then you've gotten the common difference, which is, I think, -5, if I'm not mistaken. Yep. Now, to find the common difference, it's either you are doing second term minus first, or the third term minus second is U3 minus U2. It's all about a term minus its preceding term, or U4 minus U3, or U5 minus what? U4. Okay. So succeeding term minus preceding term. That's the whole concept. This is how we find common difference. And I said it's denoted with the symbol what? D. Are we together? Are we together? So now you know how to find common difference, right? I'm moving on. I'm building on again. Just let me know if I can move on. Are you sure you guys understand? Just Andrew, so do you get it? Andrews, do you get me? Andrews, do you understand?
Yes.
Okay. What's the name? Oh, my God.
Yes, please.
Yeah, Jessica.
Yes.
Right. But there is another girl. Janet, yeah, Janet. I don't know if you're following. Do you understand? I think she's not with us. Let's move on. Okay, so now you know how to find a common difference, especially for the negatives. So see, look at this set of positive numbers. This set of positive numbers. To find our constant is about what? Either the second term minus the first term. So it's going to be u2 minus u1. If you're going by this, then that's going to be 3, right? 3 minus 1, right? And you will get your 2. If it should be negative, it will come out like that. Okay. Now, you see, when I create a sequence, I ask you to continue, right? So for this topic, the questions you'll be given is find this term or that term. So find the fifth term, sixth term. Okay. And yeah, of course, you just look at a pattern and you guess, right? Yeah. But how about we give you huge numbers, okay? And it's hard to actually identify that constant. It's hard. Or even if you find that constant, look, for example, 13579, you know the constant is 2, right? What if I throw a question at you that what is going to be the 100th term of this sequence? That's a lot of work. What's going to be the 100th term? Are you now going to continue the sequence? 10, 11, sorry, 11, 13, 17, like that. It's going to be tedious. How do you find a 100th term? It's going to be tedious. So that's the importance of this topic. I'll introduce you to some formulas that can guess your 100th term for you without having to continue the sequence until you get to the 100th term. And I want you to appreciate that. So we are getting there. So I've already explained UN to you, right? So it represent what? The nth. So UN represent the nth term, right? Like first term, second term, third term, okay? D stand for what? Let me look for names. Good, you got that. Common difference, yeah. Now I'm introducing you to A, okay? A, you likely meet A a lot. What is A? You must have done this in high school. What is A? So if you meet A, it represents first term, okay?
Okay.
So if you meet A anywhere, it means first term. So let's do something here. Already we know that UN represent the n term, right? So you can say UN, I mean U1. U1 is first term, isn't it? So first term can be the same as what? A, but in formulas you see A a lot. Okay. First term, which is the same as A, okay, is what? So A is what? First term. If I ask you what's U1, you subscript 1, it's subscript. That means it shouldn't be like this, but rather like this. Okay. Yeah, so if I ask you what is U1 or A is what? First term. Okay. Okay, now let me now introduce you to the formula. So now generally in exam to find the n term, okay, to find the n term, as in find the 100th term, okay? To find the n term, okay, which is un, right? Un, there's a formula we use. So to find the n term of an arithmetic progression, if I ask you to find the n term, you have to find out what kind of progression is that. Is that an arithmetic progression? Arithmetic progression is that sequence which, like, this next terms differs from what preceded them by a certain constant. So if it's an AP, then to find the n term is given by the formula, the first term a plus n minus 1. N is here. Okay, n minus 1 what? D. And you already know D. You know D and how to find D. So this is how we find the n term of a sequence. You know how to find D. And listen, no matter how you choose to find your D, because it's a constant, the answer is the same. Because the constant, the answer is the same. So someone can choose to use the fifth term and the fourth term to find his or her common difference. The answer is the same. And listen, this statement I've used, and you can use it to form an equation to produce unknown numbers in certain word problems. Pay attention. That statement I've used. Okay. I'm like, if you decide to do third term minus second term, the answer you get is the same as if you are doing fifth term minus fourth term. Because sometimes it's the same. Because sometimes they'll give you a question where there are variables. This concept alone can give you clues. Because maybe the third term is 5 and the second term has letters like a variable, maybe 4x plus 1. And the fifth term, the fifth term is a number, the fourth term, that one is also a number with variables. So you can use this concept, establish an equation, and produce a variable. Those that have in-depth knowledge with equations, this is for you. Don't worry, if you are a beginner like me, we will get there. Can I move on, guys? But I just want you to keep in mind that once it's an AP, however you find in your common difference, be it second minus first, or third minus second, or fourth minus, the answer is 1 as a constant. If it's 5, it's 5. If it's a -3, it's a -3. So there's a formula to find the nth term, okay, of a sequence. So now watch closely. I'm going to ask you a question. So we will still use our 1, 3, 5, 7, 9. What is the third term of that sequence? What is the third term of that sequence?
5.
Yeah. Now let's assume you do not know. We'll use this formula to produce it. And once it has been able to produce it, the meaning if I ask you to find the 200th term, you can rely on it, right? So 5. Okay. But the question is, what's the third term, right? U3. Okay. So A is equal to what? In that sequence, the first term was what? 1. Do you see it? Hello? Yeah, it's 1. Now, common difference. I said common difference. To find a common difference, it's what? Second term, U2 minus U1, or anything you can think of, depending on the length of the sequence. Someone can do U4 minus U3. Okay. Now, U2 minus U1, U2 is 3. So that would be 3 minus 1, right? So that's 3 minus 1. So that's equal to what? It's equal to 2, right? So we have the common difference. So now the question says find U3. It's there, but we're acting like we do not know. So that will be U3. The third term will be equal to, you write the formula A plus, sorry, you have to write the formula first. A plus what? N minus 1 what? D. Now U3, third term will be A, first term is 1. So 1 plus N. N is what? 3. Third term, so 3. So 3 minus 1. D is calculated as what? 2. So you get in 1 plus 3 minus 1 is 2. So that'll be 2 times 2. So that'll be 1 plus what? 4. Right? 1 plus 4, isn't it? Which is 5, right? So now when you go and check that sequence, the third term there was what? It's 5. Do you see it? Okay. Do you have any question for me? So you'll be playing with this because we have just 5 minutes left. So I'm going to give you a question and then you try your hands on it. Some of you are writing, eh?
Yes, we have it.
Okay, while you are writing, this question is for you. This question is for you. Find the 11th term. Find the 11th term of a linear sequence of form 4, 9, 14, 19. Oh, sorry, 4, 9, 14, 19. Dot, dot, dot. Oops. Would you get it? Like 4, 9, 14. Yeah, 19. 19. Okay. Yeah, so this is for you. So, in this question, they even told you the sequence. You don't just start by solving, by writing formulas. Understand the question. They said find the 11th term of a certain sequence. Ask yourself, what sequence is this? If you were not told, you have to analyze the sequence to find out, does each term differs from the preceding term by a constant? If so, then it's an AP. But this one, it was even specified in the question that it says linear what sequence, right? Linear sequence. So, um, call me in 5 minutes. Just a moment. Call me in 3 minutes. 3 minutes. Having a Zoom meeting. Yeah, you get it. Find 11th term of a linear sequence of the form. So here you are told it's a linear sequence, right? So now you're free to go. But have a broadened mindset. Okay? Guys, are you there? I'm speaking to myself. Hello.
I said we are there.
Okay. Patience, I miss your voice for 2 months now. Okay. So you might have to send your solutions to my inbox. Okay, guys, you know what? Time is due and I have another session to hop on. So when you are done, text your solution to me on my WhatsApp as we do every time. I'll also send you some questions to try your hands on it. Is that okay? Hello?
Yes, sir.
Yeah, I'll send you questions to try your hands on before we meet tomorrow. I'm gonna drop your assignment right now. Okay, so that is it. Any question for me? Tomorrow you all must come. Today we can't create any timetable because of your attendance. So just come tomorrow and then we'll continue what we've been doing, okay? Then based on the attendance, we can form a timetable because you are more than this. All right. Yeah, thank you for joining. You guys do not like the video. If it's something nice and educative, you should like it and then um, subscribe to the page if you haven't and share to your friends as well. See you in our next lesson.